So thank you for this opportunity to speak here. My presentation is going with the flow from sediment cores underwater to 3D stratigraphic models in ArcGis to site management. Since the 60s, experts have been conducting underwater research in the lakes of Zürich on the pile dwellings, and they have nearly 60 years of research, of course, accumulated a lot of data. In the next 15 minutes, I would like to present the different types of data and models that we use in our site management. As you will see, there are 3D descriptive stratigraphic models, episodic lake bottom surface models, predictive hydraulic models, post-dictive geotechnical models, and hypothetic geochemical models, and you see too many ideas for the future. Sadly, Niels Bleicher, the co-author, could not be here. He is the dendrochronologist and project manager of the last big excavation that we conducted in Zürich. So I have to take his place. I have been working as an underwater archaeologist for the department since 7 years. So I have been conducting most of the data accumulation, and I've also generated the 3D models and the automated process to create them. First, a bit overview. What are we studying? The pile dwelling phenomenon can be found on nearly all alpine lakes surrounding the Alps, especially France, Switzerland, Italy, and Germany, also Slovenia and Austria, whereby most of the sites lie on the shores of the Swiss lakes. Surrounding Lake Zurich, we can record over 100 of those pile dwellings. In 2011, 111 of those sites were selected as a UNESCO World Heritage. In the canton of Zurich, 7 of these were included. Which is quite interesting because it's one of the only UNESCO World Heritage that nobody can see. So it's a hidden, sunken and forgotten part that we are trying to present again. The pile dwelling sites are one of the most important archaeological sources for the study of early agrarian societies in Europe, between 5,000 and 500. In Switzerland, it's 4,200 to 800, but it's just another one. The waterlogged conditions have preserved organic matter that contributes in an outstanding way to our understanding of significant changes in the Neolithic and Bronze Age. The site not only offers excellent preservation of plant remains, which produce detailed information on the ecological surroundings and the economy, but also allow us rare insight into the lives of these early agrarian societies. Even the tools, as you can see, remain in an exquisite state. One of the most important organic matter preserved, of course, is the wood, especially the piles. These piles are remnants of the former platforms or houses. In the excavation of Zurich Opera, the last big one we conducted, we documented over 16,000 of these piles. Of course, this means it's a good toll house for every dendrochronologist out there. These piles, of course, don't belong to one phase. They are part of a grand local stratigraphy. Here is an impression of the deposits in Zurich Opera. The bright sediment consists of natural calcareous lake marl, whereas the dark layers represent the anthropogenic waterlogged organic cultural deposits. To document and protect these sites is the main task of our department. We monitor all sites and identify those threatened by erosion. Building on that, we try to identify what is causing the erosion. Wind-induced waves, ship-induced waves, swimmers, private yacht anchors. The question is always where to invest our limited resources. To achieve a holistic inventory of all sites, we have used different methods for site analysis and modeling. I will use the example of a site in Zurich to show you what our holistic inventory contains. As you can see, a holistic inventory should, of course, include all archaeological information, settlement context, the site management information, and it can all be split up into two groups. We have the dynamical data that most of them have to be modeled, and the static data, which is the stuff that's still there in the ground that we are trying to study. So first, we need to know what is still around and where. Else put, we need an approximative 3D model of the cultural deposits at and under the lake's bottom surface. Minimal invasive methods include two kinds of core sampling that we produce, open probe and dry ice probes. The open probes have a fixed length of 1.50 m, while the dry ice probes can go as deep as 4 meters with a tripod and 8 meters with an excavator. These give us local stratigraphy and can also be used to acquire C14 probes. We enter these stratigraphical point data into a database and feed them in a GIS system. With the correct data model and just a few Python lines, we can automatically construct a digital 3D model of all individual coring results. They form the basis of our descriptive stratigraphic model. Honestly, though, especially when you see the interpolation, this is mostly descriptive, but mostly interpolation, because the taphonomic processes are a little more complicated. But still helps us to figure out where to start. The next step is to construct a surface model. We use the core results for this, and sometimes we add remote-controlled sonar data. They have a higher information density, but less information on the actual sediment. Here we are experimenting with an autopilot fish feeder and a fish finder. So. A third method is the surface surveying. Here, an area specified as endangered is freed from mud. The artifacts are collected per square meter, and all the piles are measured with an underwater GPS, and a sample is cut from each pile. Since it is hot right now, we also create SFM models if we need them or if it helps. At this point, we have some stratigraphic point data and a denser point cloud of the surface, of the lake surface. Now we need to know where has the most erosion taken place and where will the most erosion take place. The traditional method for the first question are the erosion controls. Here, a fixed installation on the water is used to measure periodically if erosion has occurred. These installations include modern piles, historic piles, or to get a surface profile, a set of piles between which a line and a tape line can be fixed, allowing a measurement from the line to the lake bed. With this. We are working on a method to determine erosion through repeated episodic measuring with the button boat, as I said before. Comparing the results should give us information on accumulation or erosion. However, this is still a work in progress and not very detailed. Now we have a stratigraphic model and a surface model. To get to an analytic predictive model, we can add measurements of the hydrodynamical exposition of the site. Here, wave patterns, current speeds, particle concentration, particle accumulation, and more is measured. Combining these dynamic data with our static data allows us to predict certain aspects of the site. For this site, Hurten-Seefeld, the combination of our interpolated cultural layers and the hydrodynamic measurements reveal the greatest point of attack from the erosion. Thanks to these models, we can formulate the best way to protect the site from its most imminent threats. As you can see already, when you created the model first, you can already see that a second layer is already pushing out of the surface, which already gives us some indication that something is going on there. And when we combine it with the current, or the hydrodynamic measurements, you can see that the biggest area of attack, or the biggest area, is right here. So. Seeing as we are still archaeologists and want to learn about the past, modeling only future erosion and protecting the sites would be rather unsatisfying. Therefore, numerous ways to reach insight to the past are utilized. More specifically, there have been a number of difficult problems related to the interpolation of the cultural layers. Some of these problems were related to different aspects of taphonomy. Primarily, there were two aspects: the original paleotopography and the question of how exactly the organic material was preserved. If we can't explain what is preserved and what is lost, we can't quantifiably evaluate the excavated results. To address these points, we took a first step towards modeling the geochemical diagenesis of the waterlogged organic deposits. To do so, we mainly used results from the ecological literature on organic degradation. Second thing we did is we involved geotechnical experts to model the consolidation of the stratigraphy over the millennia. Employing an iterative finite element model of the sediment compaction, these colleagues needed information on the course of the sediment build-up over the years. This is, luckily for us, we actually took in account this on the last big excavation, as you can see. These are the modern, underneath is the prehistoric site, and on top is the modern archaeological build-up we found. And through all these, they were able to reconstruct the topography in 3200 BC on the site. And they were accurately able to also, this is what we have seen in the excavation, and they were able to model how this was this shift in the cultural inner layers happened. What next? A reason we are here is to get inspired from your ideas, especially with Bayesian models and everything. But even better, maybe to somebody gives us ideas how to come up with a process-based model, which would include all known variables and could accurately predict the stratigraphical sequence we can see underwater today. Thank you for your attention.
Thank you very much. It was really interesting. Does anybody have a question?
Yes, I have a question. Two questions, very short. Please, depth of the cultural underwater cultural layer, and second, distance between probes, the one you were testing. Thank you.
It depends on the sites. I can give you. Here you can see the distance of this site that we probed. These are all probes we made, and here they are 5 meters apart. But it depends on the site. Sometimes it's only 10 meters at first, but the deeper we go per site. But as we said, it's over 100 sites only in Lake Zürich. But we also conduct researches in 5 different lakes, which all have sites. So depending on how many times we were to the sites, there was going to be more cores. But this is one of the highest resolution we have for a site. And underwater, yeah, the sites, the maximum in Zurich is 5 meters deep to the lake. And then in the sediments, depends. But usually, sometimes they're already on the sea bottom, so they're open and they're endangered of erosion. And
Okay. We have Niels, another question.
Thank you very much for this very interesting presentation. I was wondering, apart from the density of the coring, About the georeferencing method you use, I saw in one of the slides you were using a kind of a buoy for taking the measurement. What was the level of accuracy that you?
It's under 5 centimeters. So yeah, this is the maximum. Yeah, you can reach on the water. I mean, before this method was created by our team, or at least we gave it. It was our idea to create something like this, and it's really good because you can use it underwater. You can press a button, and then it's catch. But yeah, 5 centimeters is. But it also measures the depth and everything, right?
Okay. Any other questions? Okay, I have a question. Because I'm working on a pretty similar case, so I wanted. So your question was how to make a process-made model, right?
Process-based, yeah.
So don't you have all the information from the formation processes that have taken place in the settlement that you could maybe use?
Yeah, for opera we would have it. Yeah,
You
we would have all the information, but we don't have the time or somebody who has the right idea to do it. Or the
I mean, but there are sites that for example, microstratigraphic analysis or micromorphological analysis has been made.
Yeah.
So, is there a way to integrate this data into your model, or are you looking?
We are trying to integrate everything we have right now. So this is a work in progress. That this model integrates everything we have.
Okay.
Yeah. Somehow.
Okay. So another question.
I have a question regarding chronological data that you must have at your disposal. I assume very detailed from all the wood. How does this change your position in trying to reconstruct all the processes? Or what big of an advantage is it as opposed to, I don't know if you have experience with other sites where this is not the case?
Well, I mean, underwater it is. If you see the layers, it is also, it's not that difficult. It's most of the time it's very simple stratigraphy. So I think Harris matrix would be, just that the dates would change, but otherwise the layers on top of each other are younger, and the one on the bottom are older, so you can't change that. So all that is changing the wood is helping us, especially in to recreate the settlements, the houses, and stuff like that. But not really the chronology of the stratigraphy is it doesn't really change. So you mean it's not connected really? Or... Yeah, of course we connected. Yeah, we tried, of course.
Do you still have any challenges? Right?
Well,
it's a naive question.
Well, the biggest challenge is still that only oak is the one wood that is, best for dendrochronology. So all the other woods which they also built with, we still have to look into that and get chronological data from them, which is being done right now. But and all through the 60s, most of the sites that specifically oaks were pulled out. So from most of the sites, we don't really have any other data. So we only have the oaks, which we knew we can have a dendrochronological date. But it also showed that opera, which was really good excavated and good. You can see that oaks were also used only in a certain time, and in later times they used different kinds of wood. So we missed all those later times that didn't use oak. So this is the biggest challenge right now.
So is someone already working on a dendrochronological sequence for the other?
Yeah. Niels Bleicher, the co-author.
Okay, so thank you very much.